We are moving on to take a look at log functions as inverses of exponential functions. Now, the word inverse might be new to you. You've probably heard it before, but we want to make sure we review what an inverse is before we talk about it with logarithms. The inverse of a function switches the input and the output. That's important. So, normally you have a function and you plug in the x and you get the y value, input, output. So, for example, if A, right here, if A is my input and I put it in the function, I might get a B. Or you could say this is X and then you get Y. Okay? When you do an inverse, it's the other way around. So B goes into the inverse function and gives you A. To find the inverse of a function that is in an equation form, follow these steps. Switch the x and y and then solve the equation for y. So that's going to be pretty simple for you. Find the inverse of each. And these aren't even logs or exponentials. This is a regular linear equation, right? I have y equals 3x minus 15. I want to find the inverse. So I switch my x and my y. That's an inverse. Y becomes x. X equals 3y. My x becomes y minus 15. Okay? So x equals 3y minus 15. Now you solve for y. Now we already had y by itself, but that was the original function. When you switch the x and the y, you're creating a new equation and you solve the new equation for y. So now how do I solve for y? Get the 3y by itself. I'm going to add 15. Pay close attention to this lesson, guys. This might be totally new to you. X plus 15 equals 3y. It's a 3. We still don't have the y by itself, so we're going to go divide by 3. Divide by 3. And there it is. That's my, so if I go y equals x plus 15 over 3, that is my inverse function. This function is the inverse of this function. Okay, we'll talk more about what that means on a graph and what the point of this is in a little bit. I just want you to get used to how do you do it, okay? Okay, purple. All right. This one here. Now, this one gives me f of x. So I'm going to say, just make that a y. Y equals x squared plus 5. Remember, f of x is the y. So now we're going to switch x and y. Okay, I'm going to switch colors. So instead of y, I put x. Instead of x, I put y. Notice how everything else stays in the exact same spot, okay? Now I'm solving for y, so I'm going to subtract 5. And I have y squared equals x minus 5. And now I need y, I have y squared, so I take the square root. Y equals the square root of x minus 5. So this right here and this are called inverse functions. What I would do here is I would change the y back to f, but instead of just, you can't say f of x, right? You can't say f of x because this is f of x. So we have to have another name for this, so you can call it another letter like g of x and say f and g are inverses. Or what you do is you use this symbol right here. F raised to the negative 1 power is a symbol for an inverse. So if you ever see f to the negative 1, they're asking you to find the inverse, even if they don't say inverse. Okay? We could apply these skills to what we just learned about logarithms. So now what do? Switch the x and the y. Here's an exponential. So now it's going to be x equals 3 to the y. X equals 3 to the y. The problem is now the exponent is a variable y, right? So we need logarithms. So how do you turn this into log form? Log base 3, remember doing this? Been doing this for weeks now, right? Log base 3 of x equals the exponent, and the exponent is y. Log base 3 of x equals y. There is my inverse of this. How about this one? Well, f of x is y, 1/2 raised to the x. Now, let's do an inverse. X equals 1/2 to the y, 1/2 raised to the y. Now, I need logs because I can't leave it like this. I can't leave x equals and I got to get it to be y equals, but my y is an exponent. So it's log base 1/2, log base 1/2 of x equals y. There it is. There's my inverse function. How about given a log? Okay. Switch the x and y. Okay. Now convert it to exponential form. Because here's my y over here, right? Base 6 raised to the exponent. Remember, logs equal exponents. The log equals the exponent. So that x is my exponent when I go to exponential form. Base exponent equals my amount. My amount is the y. Look at that. 6 to the x equals y. That's my inverse. Here's another one. Y equals log base 7 of x. I just put the y in for g of x. Now switch the x and y. This is my inverse, but I can't leave it like that. 7 to the x equals y. Take a look at these. Take a look at these 4 examples. Where's my highlighter? Come on, highlighter. Okay. Started off with y equals 3 to the x. It became log base 3 of x when I did the inverse. Started off with 1/2 raised to the x. It became log base 1/2 of x. Ended up with 6 to the x. It became log base 6 of x when I did the inverse. Ended up with 7 raised to the x. Started with log base 7 of x. So you can see the relationship between the exponential and the log. When you do the inverse of an exponential, you get a log. When you do the inverse of a log, you get an exponential, and that's because you're switching the x and the y. Therefore, the exponent switches position. Instead of the x being in the exponent, the y is in the exponent. All right, so we're going to do more of these, and I think you'll get to see that a little bit better. All right. So example 3, 500 invested at 5% per year. We've been doing these, right? We've been doing a lot of this stuff here. Get that pen back. Determine the inverse of this function. So here's a function, right? Switch x and y. X equals 500, 1.05 to the y. All right, so now divide by 500. So now I have x over 500 equals 1.05 to the y. I don't want to leave it like that. I want to put it in log form. So y equals log base 1.05 of x over 500. And again, this, I know that might be a little confusing. This just comes from experience and practicing it. You're just getting the base that you need to do the work in class tomorrow. Use this, so here's the inverse. Use the function to determine the number of years, so till it's worth 800. So now you're given the money, which is the x value, in the inverse function. Normally the money would be the y, right? But this is an inverse function, so the money is the input. The money is the x. Okay? So this is 8 over 5, whatever that is, right? And then calculator, did this ahead of time just to save time. It ends up being log of, this is 1.6. So it's log of 1.6 divided by log of 1.05. Change the base formula. And that gives me 9.6 years. 9.6 years. And then this was on, this is already done for you, right? Exponential is this on a graph, and then when we graph these, it's a reflection over the y equals x line. So we're going to talk more about this in class, where this y equals x line is this. When you do an exponential, it looks like this. When you do a log, it looks like this. And we're going to see that in our example here. So we're going to do this first, and then we're going to do the domain and range. So graph 1.8 to the x, and that's just from your calculator. So rather than bring up the calculator, I did this ahead of time to save time for you. So the points are, and I'll just read them off to you, -2, -1, 0, 1, 2, 3. Okay? And that comes out to be, it's 0.3, I'm rounding, 0.3, 0.55, don't have a lot of room here, 1, this is 1, 1 is 1.8, 2 is 3.24, I know you can't read this, and 3 is 5.8. Okay, so let me write that back. Let me do that up here. Got this new software that's not working very well for me here. 0, 1, 2, 3. Okay, so here's my 1.8 to the x. 0.3, 0.55, 1, 1.8. God, the calculator just does this for you. 3.24 and 5.8-ish. And this is just rounded, okay? Calculator gives these values to you. Now we'll graph them. Okay, so extend the page a little bit here. What happened to my graph? My graph got cut off. Okay, so -2.3, so that's just like right there. Tough to graph on here, and then it's 0.5, and then 0, 1, 0, 1, 1.8, right about there. 2, 3.24, a little bit above 3, and then 4 is like 5.8, 1, 2, 3, 4, 5.8-ish. Okay, so there we go. So there's our exponential function. See what it does? We already knew that. We already know that exponentials form this pattern. Okay? Now when I do the log, if I want to graph the inverse, think about it. Inverse is just switch x and y. So if I'm switching the x and the y in the formula, the x's and y's in the tables are just going to switch. So if I want to graph the inverse, which I know the inverse is going to be log base 1.8 of x. I already know that from my exercise earlier. I know that this is going to be my inverse, log base 1.8 of x. And I want the inverse table. I'm just going to draw an arrow. I'm going to change colors real quick. Okay, so now my table is going to be reversed. So instead of -2.3, it's 0.3, -2. Instead of -1.55, it's 0.55, -1. Instead of 0, 1, it's 1, 0. See what I'm doing? Just taking these points here and flipping them around. 1.82, no, 1.81, 3.22, 5.83. And now you graph those. And what happens is, say 0, it's 1, 0, hits 1.821, right? And it hits, it's very hard for me to graph on this. You could do a better job than I can on this. and then 5.83, something like that. So what's going to happen is it's going to do this, kind of. And that's that reflection. See how one's going this way, one's going that way? If you draw that y equals x line, you should know about, from Algebra 1, hopefully you remember y equals x. That's when all the x's equal to y's. You draw that line, it's always a reflection over that line. Because, and you learned in geometry, you reflect over the y equals x line, the x's and the y's switch. So inverses are really just reflections over the y equals x line. When you invert exponentials, you get logs. When you invert logs, you get exponentials. That's what this whole lesson's about. The domain, well, the domain of exponential, we already know, is negative infinity to infinity. And the range is only 0 and up. 0 to infinity, because it doesn't go below the x-axis. It only goes from here up, right? So the domain and range, remember, domains x's, ranges are y's. For the inverse log, right, log function, you switch the x's and y's. So the domain switches with the range. The range is now 0 infinity, and domain is 0 infinity. The range becomes negative infinity to infinity. All right, long enough. We're going to do more in class tomorrow. See you then.